Hello, everybody. Welcome to I guess this is Unit 4. Unit 4. Exponential functions. So hopefully, I know that at the time of posting this video, we haven't technically finished Unit 3 yet, and I guess again, I'm not entirely sure. I think Mr. Tremoli has given you some exit cards and some assignments and some quizzes to do. I definitely know that there is a quiz on Friday, so hopefully everybody else is kind of aware of that and are preparing well for the quiz. And hopefully, the lessons that I was posting on YouTube are helping clarify some of the doubts that you may have. I will say I've also been thinking about ways to facilitate easier communication, especially if you have a question on the spot. Like I realize that it is kind of cumbersome to like either go to the hub or like email somebody. So I am going to be, I have recently broken my rule on social media, and I have downloaded Snapchat. So I will be posting a link to my username and stuff on the hub. So if you wanted to add me, that would be great, and you can hopefully more easily take pictures of maybe questions that you were stuck on, or like a problem that you were doing and you got stuck in the middle, and you wanted to know whether the answer was right or want to know where you went wrong. I think it'd be easier just to take a picture of the question or your work and show it to me, so that it'd be easier for me to help you or answer whatever questions you may have. So that's what I'm gonna be doing. So I will put the post. I mean, my username again. I'm pretty new to Snapchat. I don't know what the ways to operate it and stuff, but hopefully that will be a learning experience for me. But in the meantime, without going too far away, we're going to be quickly talking again. This is just to start off the video this week. I will be updating content over the weekend. So 4.1, 4.2, I believe it is opening on Tuesday because, of course, Monday is Easter Monday, so it's a holiday. So happy Easter, everybody. Enjoy your even longer weekend. It's just all a big weekend at this point. So but those of you who do celebrate Easter, hopefully we are still following social distancing rules, but make the best of the holiday, and happy Easter to those of you who are planning on doing something special with family, friends. It's a good time to get together with those of either virtually or with those of you, those family and friends that you can get together with by virtue of living in the same household. Okay, I'm getting distracted. This is a short lesson 4.0. The O indicating that this is basically whatever stuff we did in grade 9, grade 10, kind of base knowledge, if you will. Base knowledge of exponent laws. So again, we're gonna briefly talk about some of these laws. If you have the same base and you're multiplying two bases, you have to add the exponents, and this can go anywhere from like the easiest case would be like 2 to the 5 times 2 to the 7 equals 2 to the power of 12, because you do 5 plus 7 equals 12. It could be even when you do like 2 times 2, hopefully we remember that we have invisible ones as exponents. If we don't have any exponent, that's kind of important. So 2 to the 1 times 2 to the 1 is actually 2 squared. 2 times 2, 2 squared, right? Because we're doing 1 plus 1 is 2. And this works the same way with variables as well. When you multiply two similar bases, you have to add their exponents. And this is a very good extension to that. Almost when you divide two bases, you have to subtract the exponents. I say extension because technically you can combine this with the rule that we've also learned, that hopefully most of us have learned in grade 9 about the 1 over x, or the reciprocal, or the negative exponent. And that's kind of where we get this idea, but think of it as like if you divide, for now we can say if we divide exponents, we are dividing bases, we are subtracting the exponent. So likewise, 2 to the 7 divided by 2 to the 5 equals 2 to the 2, because 7 minus 5. 2 divided by 2 is 2 to the power of 1 divided by 2 to the power of 1, which is in fact 2 to the power of 0. And we also will remember that anything to the power of 0 equals 1, except of course 0 to the power of 0, which actually equals 0. So yeah, that's just good to remember. Anything to the power of 0 equals 1. That's why 2 divided by 2 is 1. Still follows the exponent law, still works, because 2 to the power of 0 is equal to 1. And here we have a power of a power rule. If we have 2 to the power of 2 to the power of 5, we're doing 2 to the power of 2 times 5, which is in fact 2 to the power of 10. And this of course works with fractions as well. 2 squared to the power of 4 times 1 over 2 is 2 to the power of 4 times 1 over 2. You can cross cancel here and get 2 to the power of 2, which is 4. But yeah, we'll solve some of the examples of this, so hopefully we're seeing where we're going with this. And again, hopefully this is mostly review based for most of us. We're recollecting instead of learning this afresh. So again, same base, you're multiplying them, so we add the powers. Nice and easy. Same base, we are dividing them. So we subtract 7 minus 3. Again, it always goes numerator minus denominator because, well, I didn't say always, but it depends on where you're moving it. Technically, you're moving this 3 up to the numerator, right? You're writing your answer as part of the numerator, so you do 7 minus 3. Again, so I hope that didn't confuse anybody. If that did, just ignore that, and it's not really super important. Okay, when we're multiplying, of course, we have to multiply the numbers first, just like we would any simplification of algebraic expressions. 8 times 2 is 16. Y to the power of 5 plus 1 is 6, so that's 16 y to the power of 6. Here we have a power to the power law, but we have a bracket. So it's important to remember that this 4, the power of 4 applies to everything inside the bracket. So this is, I'm writing an intermediary step, which most of you hopefully would not need. 3 to the power of 4, a squared to the power of 4, and b to the 5 to the power of 4. It's because this 4 is a power to the 3, to this term, this part of the term and that part of the term. So 3 to the power of 4 is 81. This is a to the power of 2 times 4 is 8. B to the power of 5 times 4 is 20. So that is our final answer. Same rules go here. We only collect terms with the same variable, the same base in this case. So 32 divided by negative 8, I'm going to cross cancel this and get a negative 4. I am moving the negative to the numerator, as is custom. A to the power of 4 divided by a. 4 minus 1 is 3. 3 minus 2 is 1, which I will not write. 12 minus 4 is 8. So that's that. Again, multiply the numbers first. I have a negative 1 times a negative 5, which is positive 5. 2 plus 2 is x to the power of 4. 1 plus 2 is y to the power of 3. Continuing, we have here we will again follow kind of bedmass rules. We always have to keep bedmass in the back of our heads. Hopefully we're doing that. So here we have a division, but first we have to take the exponent of this bracket. So first we do the exponent and then we divide these two different terms here. So again, I'm not gonna do the intermediary step. Negative 4 to the power of 3 is in fact negative 64. A to the power of 4 to the power of 3 is a to the power of 12. b to the power of 1 to the power of 3 is just b to the power of 3 divided by 8a to the power of 4b. And here, once I do the division, again, I'm going to rewrite this, which of course you don't really have to do. I'm just cross cancel negative 8, a to the power of 8, b to the power of 2. So 12 minus 4 is 8, 3 minus 1 is 2. So this is my final answer. Hopefully we will, we'll be aware that the negative 4 to the power of 3 is like negative 4 times negative 4 times negative 4, which is negative 64, which is coincidentally the same as negative 4 to the power of 3, or if I just write negative 4 to the power of 3. This is different. This is negative of 4 times 4 times 4, which is negative 64. Well, the answer is the same, but the process we're doing is slightly different. Because, and it's important to know whether the brackets are there or not, because, for example, if it was in fact 2, if it was an even power, negative 4 squared would be negative of 4 times 4, which is negative 16, whereas negative 4, if the negative sign is included in the bracket and the square applies to the negative, we're actually doing negative 4 times negative 4, which is positive 16. So there is a difference if there's an even power. So even powers, you have to be especially careful and just make sure to check whether the negative sign is inside the bracket or outside the bracket of where the power applies. So that's super important to remember. So here we can kind of see that this negative 2 is, the negative is inside the bracket to which the power applies. So we're doing negative 2 times negative 2, which is a positive 4. A to the power of 5 times 2 is 10. B to the power of 2 times 2 is 4. 4ab, 10, 8, 11, b, 6. All right, so here I'm gonna do some cross canceling first because I can, and hopefully we will. From our second unit, we will be appreciative of the fact that I can only cross cancel these two numbers because, again, I'm multiplying everything on the top, multiplying everything on the bottom. I can cancel, and I'm only canceling the 4 and the 5. Don't touch this 4 because I'm just dividing this by 2 and this by 2, and that's all I'm doing. So here I kind of have 2a to the 11, b to the 5, because 10 plus 1, 4 plus 1. Divided by 2. I mean 8, because I did 2 times 4 and got 8. Oops. And here I have 5a to the 11, b to the 6. This is 8 over 5. In the numerator, a to the 11 minus 11 is a to the 0, which is in fact 1. So I'm not going to write that. And here I have b to the in fact negative 1. Because I do 5 minus 6 and I get negative 1. A smarter way, a better way to write this is actually 8 over 5b, as we know that b to the power of negative 1 is actually 1 over b. So hopefully we remember that, because if we have b to the power of negative 1, we will remember that we take the reciprocal of the base, so we flip the base, 1 over b, and change the sign of the exponent. And again, 1 to the power of 1 is just 1, so this is 1, b to the power of 1 is also, this is just 1 over b. So the b is technically part of the numerator, so it's 8 over 5b is my final answer. You can also, if you wanted to think of it as bringing the 5 down instead of bringing the 6 up, so you do 6 minus 5 in the denominator. I guess you could think of it that way, but that's kind of confusing. So make it b to the power of negative 1 first and then flip it is probably the easier way to go. Again, we're going to do this last question before I sign off. This will be a short video. And again, I will be updating more content over the weekend. Take your Easter break off, and then hopefully you'll be back. All gears firing on Tuesday. So we'll hopefully catch up with you then. But again, negative 3 to the power of 4, it's an even power. The negative sign is part of the bracket, so there's 4 negatives that I'm multiplying. So this is actually positive 81. X to the 4 times 4 is 16. 2 times 4 is 8. y to the power of 2x, oh, whoops, 2 squared is 4, I completely forgot about that squared, x to the power of 2, because 1 times 2, and 3 times 2 is y to the power of 6, 8x to the 23y, so I guess I can remove this 8 and kind of put a 24 there. Again, if you, I'm just doing what normal, like what you would normally think to do, but if you are, you know, if you can predict the next step, if you will, you might want to leave the 8 and the 3 as it is, because in fact what I'm going to do now is I'm going to try and cross cancel some stuff from here. So technically I'm going to take out a 3 from here, so that this becomes an 8, and a 3 from the 81, so it's 27. And in fact the 4 and the 8 are going to cancel to give me a 1 and a 2. So maybe leaving the 8 and the 3 would have been easier, but either way, same answer, not a big deal. So again, I'm going to do this in one step. My number is 27 over 2, right? And again, I'm going to put all my variables in the numerator first before I decide whether to flip them to the denominator or not. And here I get, we'll see here that I have x to the power of 16 plus 2 minus 20. So 16 plus 2 is 18. 18 minus 20 is negative 2. And here I have y to the power of 8 plus 6 minus 1. So 8 plus 6 is 14, minus 1 is 13. And hopefully we can see here that I don't want a negative exponent, so I am going to leave the y to the 13 on the numerator, but the negative exponent I am going to move to the denominator and make it positive. So if the exponent is negative, you kind of can just flip the base. So if the base was in the numerator, you bring it to the denominator. If it's in the denominator, you bring it to the numerator while making the exponent positive. So again, that is something we're going to get into in detail in this lesson, basically applying this rule, integer exponents. But hopefully we are doing some practice. The answers are given. I don't feel like I have to go over this, but if you do have a concern with, maybe you're not getting some of the same answers, and you're like not sure where you went wrong, again, feel free to snap me. Apparently, I think that's the correct. I think I said that right. But yeah, send me a snap, and I will get back to you. I will talk to you guys again. Have a great Easter, and yes, talk to you soon. Peace.